Hi. Having seen on our field trip around the school site how these principles of relative dating actually work, what I want to do is look at some of these in turn and focus on one, if you like, technique per lesson. We're going to start out with the most fundamental of these, the principle of superposition. And I don't think there's anywhere that illustrates this principle more clearly than here. This is the Grand Canyon. If you go to the Grand Canyon, and if you do get a chance to go, it's just amazing in terms of its scale. Um, where you stand here on the rim, you're about a vertical mile above the river that eroded this canyon at the bottom. The far rim is something like 10 miles away. It's a couple of hundred miles long. It's an enormous hole in the ground. But this hole in the ground reveals to us a very long geological story. If you want to find the oldest rocks in the Grand Canyon, you need to go down to where the river is, right down to its bottom. If you want to see the youngest rocks in the Grand Canyon, which are about Permian in age, you'd be here, right up on the rim of the canyon. The further you go down, the further back in time you're going. The more you climb out from the bottom of the canyon, the further forward in time you're going. So as an idea, it's a fairly straightforward one. And it's one of the ways that we can work out how old rocks are. Now there is one but. To work out or to use superposition, we need to know which way up the rocks are. Are they in the same direction or the same orientation that they formed? That's what we call them being the right way up. Or has tectonic processes turned them upside down, making them the wrong way up? Now the way we tell is by using sedimentary structures. We learnt about these way back in theme 4. You might want to go back and just check out the work we did on them then. These are 3 from the examples that you've got on pages 4 and 5 of your booklets. The first one here is cross-bedding, laid down where there's a flow from a river or the wind, and we get these beds at an angle to the main beds. That tells me that these beds are the right way up. The second structure here is graded bedding. This is where we see the biggest grains, so say pebbles, being deposited first at the bottom of a bed, and then the finer grains, say sand, being deposited at the top of the bed. If you look at this particular image though, that's not what we're seeing. Here we're seeing the coarser grains at the top, the finer grains at the bottom. That tells us, as geologists, that any bed like that is the wrong way up. It's been turned upside down. The final structure we have here are mud cracks. These form on the top surface of muddy deposits that dry out. The mud shrinks and cracks and then fills up with whatever sediment comes afterwards, which you can see happening here. These mud cracks get narrow as they go down so that we can tell these particular rocks are the right way up. So, what I'd like you to do, remembering the geological timescale that we looked at in the first lesson of this and using the one that I've given you on page 2 of your booklet, I'd like you to work out the age sequences that you can see in the photographs on pages 4 and 5. Each of the beds there is from a different period. Can you work out which one they are? I'll give you one more clue as well. Where beds are tilted, geologists describe that as they dip. And beds dip in the direction that they get younger. Okay. Press pause now and have a go at answering those questions. Remember the sedimentary structures, remember the rule about dip, and use that geological timescale. See what you can come up with. Okay, let's have a look at some answers here. This was our first sequence of beds. You can see we've got two beds labelled up here. We've got the Ordovician beds and the Carboniferous beds. That means that they must be older on the left, younger on the right, getting younger in the direction of dip. So we know then that one must be older than the Ordovician, which is Cambrian. Two must be younger than the Ordovician, which is Silurian. Three is older than the Carboniferous, so it's Devonian. 4 and 5 then, the Permian and the Triassic, must be younger than the Carboniferous. The second photograph, here we can see something slightly different. We've only got one bed labelled here, the Carboniferous, but we have got that graded bedding that we know is upside down. So these beds have been overturned. So the normal rules of superposition don't apply. So in this photograph, the youngest bed is actually going to be at the bottom of the cliff. It's the Cretaceous period. We then, as we work our way up the cliff, because these beds are upside down, are getting progressively older. So we get to bed 4, just in this cliff below the Carboniferous, but actually younger than the Carboniferous, the Permian. And then the oldest bed here is at the top of this cliff. Now this is quite unusual. Most of the time beds are going to be the right way up, but we do need to watch out to see if they've been overturned. Our last photograph here has another sequence of beds. This time we have our mud cracks to tell us that these rocks are the right way up. So these rocks are going to get younger in the direction of dip. So our youngest rock here is going to be furthest in the direction of dip. That's Cretaceous. Underneath that then we have the Jurassic and the Triassic. We've labelled up the Permian. So bed 4 must be older than the Permian. So it's Carboniferous. And the oldest bed here is the Devonian. Okay, as we see the sunset over the Grand Canyon, we can think about how we apply this principle of superposition. It's relatively straightforward. Oldest at the bottom, youngest at the top. But we just need to be careful to make sure that those rocks are the right way up. If you're asked a question about this in your exam, there will be some clue to help you work that out. We just need to watch out for it. Next time, we're going to start thinking about how we can actually use fossils to help us work out this idea of superposition. I'll see you then.